Hey there, Year 12s. This is exercise 3B. I thought I'd just make a nice video to do example, so 9B, to do example 4, where you're trying to use the recurrence relation to talk about reducing balance loans, okay? So what is this? So you're borrowing some loan and you owe the bank a certain amount and you need to pay them back on a regular basis. So here it says part A, you know that you've got Alyssa's loan can be modeled by the recurrence relation. So we can see that V0 is $1,000. So Alyssa's borrowing $1,000. And we can see the recurrence relation is saying that V of n plus 1 is 1.0125 times Vn minus $257.85. So this is following on from the previous example. If you weren't following it, essentially it's 15% per annum compounded monthly, and monthly repayments is $257.85. This is from example 3. Okay, so we know that. I'm just going to write it here to remind ourselves. This is essentially 15% per annum. But then to change it to monthly rates, that would be what, 15 divided by 12, and that gives you 1.25. So that's 1.25% per month. Okay, so that's the rate per month. And remember the formula, if you've forgotten, Vn plus 1 is equal to 1 plus R over 100 times Vn minus D. Okay, so in this case here, all we did was we simply used R, which is our case 1.25%, and that's how they got 1 plus 1.25 divided by 100. That's 1.25% multiplied to Vn minus $257.85. So that's their monthly repayments, and that's how they got 1.0125 multiplied to Vn. Okay, so that's just a recap of example 3. Now it says here in example A, use your calculator to determine recursively the balance of the loan after Alyssa has made each of the 4 payments. So we want 4 payments here. So I'm going to go back to my calculator, and here we go. We start off with $1,000, and I'm saying times by 1.0125. And then I'm minusing $257.85. So press enter. That's payment 1, payment 2, okay, payment 3, payment 4. Okay, so what you can see here, what is interesting is after the 4 loans, you can see the amount that's reduced over time. I'm just going to screenshot this. Okay, so I've got my calculator with the recursive payments. So there we go. Use your calculator to determine recursively the balance of the loan after Alyssa has made each of the 4 payments. These are the balance of each of the loans, and then you can of the payments. And then B, part B. Now we can see what is it asking us to do. Whoops. Part B is asking what is the balance of the loan, the amount she still owes after she has made 2 payments. Give your answer correct to the nearest cent. So in B, in part B, can you see after 2 payments, this is, oh, that's not a good, that would be better. I should have screenshotted that actually. I'm going to screenshot it again. Here we go. Let's do it. And I'm going to delete this just to help us understand. Okay, so, here we go. Let's just shrink that a bit. There we go. So we know V0 is $1,000. This is after V1, V2. So we can see that at V2, the balance of the loan is $506 and technically 23 cents. And what do they want us to round it to? It was, she made 2 payments to the nearest cent. Yep. So $506 and 23 cents. And then you go to C. What was C asking for? C is asking for, is the loan fully paid out after 4 payments have been made? No. We can see that there are still 4 cents or 4.4 cents, so technically 5 cents that the bank, that we still owe the bank. And so in this case here, they then ask, if not, how much will the last payment have to be to ensure that the loan is fully repaid after 4 payments? So in order for this to work, she can't be paying $257.85 on that last payment, because that was the last payment she made, because she will still owe that extra 4.4 cents. So what they do instead is they say, right, well, to make sure that you balance, like you totally finish that off, well, in this case, if we're rounding it off, this technically is 5 cents away, or you can be as particular and it'll be 4 cents exactly, but we can say, I guess, to the nearest cent, we just need an extra 5 cents there. So if she paid in a last payment was normally $257.85, well, there's still that owing of 0.04 cents or 49 cents there. So we can round this up to 257.89449, which you can say she can pay $257.89. But I